This is the screencast for section 9.4, example 9. In previous examples, you used either the explicit or the recursive definition of a sequence to identify certain terms, whether it be the first 6 terms or 8 terms or whatever, in a sequence. We can actually use our calculator to do that. If the sequence is explicit, it becomes a little bit more complicated, but here would be what you type in. First, you type in 0 and store that as k. The store key is right down here next to number 1. So you type 0, store, and then alpha, open parentheses, is k. Now from there, you're going to tell your calculator, take k and add 1, and then store that as the new k. And then with that colon, you're kind of telling your calculator, and then, pause, take 3, multiply by k, and then subtract 5. And then you get your next value, -2. So that would be for k equals 1 because we added 1 to k. Now we need to find the term when k equals 2. So we're going to take k, add 1 again, and store that as the new k. So instead of k equals 1, it's going to be 1 plus 1, which is 2. Then we'll take 3 times 2, subtract 1, and we get 1. 3 times 2, subtract 5, and we get 1. Then if we add 1 to k again, and so on and so forth, you're creating each of the terms forever and ever and ever in this sequence explicitly defined by 3k minus 5. If the sequence is recursively defined, you could take a sub 1, which in this case is -2, and then add 3, which you get 1. Then if you take your calculator and put second answer plus 3, it'll take the previous entry and add 3 to it. So 1 plus 3 is 4. And then if you just keep hitting second entry, second entry, second entry, second entry, so second entry, the enter key, you would keep getting the same values that we did in the explicit version of that sequence. Example 9's now try problems asked us to do numbers 1 and 5 again, but using our calculator to come up with the first 6 terms. And the 100th term, but I'm not going to keep track of pushing the button 100 times, so let's just go with the first 6 terms. So first I took 0 and I stored it as k, and then I added 1, stored that as my new k, and then used k in my definition of my explicitly defined sequence, so k plus 1 over k. My first term would be then 2. Take k, add 1, store that as a new k, put it in the definition. My new term is 3/2, and then you see the sequence laying out as it did in example 1 from this section. Number 5 is defined recursively, so all we have to do is take a1 and subtract our difference, so 4, and then do second, enter, and then tell our calculator to take the previous answer and subtract 4, and keep enter, 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 and you get lots of different terms all the way up to the 8th term if you want to.